Hi all and welcome back to Scala Collections. In our previous video, we have learned on how we can filter the data from a collection. But we also observed that the syntax was a bit cumbersome. Today, we'll explore for yield, which is a syntactic sugar or an easier way to write map filter clause. Let us review the filter syntax once again, and then we'll analyze how we can write a simpler for yield clause. So we provide a function literal that would return a boolean for each element in the collection, and we'll get another filtered collection. Let us have a look at the same problem of budget books from our previous video. So I'll quickly declare a class book, and will create a list of popular Scala books in market. So our problem was to filter out all the books that are below 30 pounds. And this is our filter function from previous video to fetch the name of the books. Here we have first filtered the books from the collection and then mapped the name of the books to our new list. Let us translate it to for yield syntax. So this is our equivalent for yield block for filter map. This for yield syntax is easy to read and would fetch you the same result as above filter block. Let us spend some time to closely analyze the syntax of for yield. First, we have specified the collection that we are going to iterate. We'll pick up each element from books and assign it to a variable book. Then we apply the filter condition or a guard condition. If the filter condition is true, then we'll pass the result to yield block. In yield, either we can output the result as book itself or any attribute of the book. Here we'll output the book name. All the result from yield will form another collection. If we remove this filter condition from for block, then for will act like a plain flat map. The for expression is really powerful and can perform query kind of operations on a collection. The advantage of using for is that you can do a lot of complex calculations, but the syntax is easy to read and understand. Below is a generic form of Scala for yield. Let us have a look at another example. This time, we'll try to find a budget smartphone for us. First, I'll declare a phone model class that has three parameters. First one is model name, then its price, and finally the size of the screen. Next, I'll declare a phone class where I'll say phone details. Phone has two fields, a company name or manufacturer name, and list of models offered by that company. And now the tedious part of creating sample data. Let me create a phone shop having 6 phone models. I will create a data for 6 popular phones, that is S8, S8 Plus, iPhone 10, the most popular phone with the widest screen possible, iPhone 8, Pixel 2, and finally Pixel 2 Plus, a phone with AI. Now let us add all these models to their respective phone companies. I'll create three phone objects, that is Samsung, Apple, and Google with their respective models. And finally, I'll create a list that has all the phones available in the market. Similar to our last problem, now I want to buy a budget phone, but this time I have a decent budget. We want to filter out all the phone models along with their company names that cost me less than £700. I believe I can get a decent phone in that budget. Um, we'll try to solve this problem using both flatMap-filter syntax and for yield syntax. Again, we want to compare both the constructs. So here I will first quickly write down the solution in flatMap-filter syntax. We'll use flatMap first because we have a list of models inside list of phones. So we want to flatten it, and then for each phone manufacturer we'll try and filter out the models that are less than £700. Now once we have collection of filtered models, we'll try and map both manufacturer name and model name. So here we end up with nested filter in a flat map and then a map. Not very nice. Now here is the same solution using for yield syntax that we have just learned. First, we'll get in each phone from list of phones. Then we'll find out the phone models. Our budget constraint will be written as a guard statement. And finally, we'll yield both company name along with model name. And here we go, the same two models again that I can buy. Nice phones though. I would love to own any of these. So here you can compare both the syntax, and for yield syntax looks a lot more neat and tidy. But as I have said earlier, for yield is just a syntactic sugar for developers to write a clean code. Internally, Scala would convert for yield block back to flatMap-filter block to evaluate the result. Let's move on. This still looks like an easy problem. However, we can also use for yield block to perform really complex queries. Here is another problem. This time, we want to fetch a company that never offers 6-inch screens. This time, we have to use nested for loop queries. So we'll pick up a phone, then we'll loop through the same list again to pick another instance of phone. Then we'll pick up a model from first phone instance, phone 1, and another model, model 2, from the second phone instance, that is phone 2. If both the phones belongs to the same manufacturer and both the screens are less than 6 inches, then we'll yield the phone. Another thing that we need to make sure is that we are not comparing the same phone from both the lists. So we have to say that model 1 is not equal to model 2. And here is the result. So Apple does not offer any 6-inch screen, even though We have done a complex calculation, and initially you may feel hard to write such a query, but the code is easy to read. Anybody who is coming new into the project and can read this code to understand what exactly is happening. We'll extend this problem a little bit more. So instead of models, what if we only want the manufacturer name? It is easy. We can right away remove the model name from yield. Let us have a look. But the problem here is that we are getting Apple twice. Once for iPhone 10 and next for iPhone 8. To get rid of dual instances of phones, we will use a function distinct. As the name suggests, the method will get rid of any duplicate instances. So let us move quickly to use distinct on our result. And here is the result. So that was all about for yield. We have observed today that why is it beneficial to use for yield instead of using a complex structure like flatMap and filter. If we would have used flatMap and filter, we would end up with lot of nested code blocks. For yield is quite popular and is used quite extensively. In my day-to-day production code, I use for yield construct while writing code for parallel executions. I hope by now you would have fallen in love with Scala for its brevity and concise syntax. Alright guys, let me know how you are getting on with Scala and what do you think when you compare flatMap-filter with for yield syntax? Which one would you prefer? See you guys next time. Thanks for watching. Please post your comments and suggestions.